Okay, I guess that we can start the session. So, welcome everybody. I'm Luca De Cicco. I will chair this session. It's the second session of the Open Dataset and Software track, and today we are going to present seven papers. So in roughly 1 hour, each speaker will have around 5 minutes to show the dataset. So please be brief and concise and leave the details for the Q&A questions. Of course, please post your questions on Slido. Please use the room ODS number 2 and tag the paper number. And we would also like to recall that we have 2 awards, the ACM MMSys Social Media Reporter Award, which you can get if you spread the word of our community using the hashtag MMSys 2020 and tag ACM and ACM MMSys accounts. So please try to be creative and talk about our papers and program. The more you tweet, the more you have chances to win. And then we have a second award, which is the Best Engagement Award. That will be awarded to the person that will be more engaging in posing questions in Slido over, keynotes and of course papers. So I think that we can start. So as I said, we have 7 papers. The first one is going to be presented by Vaira Tambawita of the Simula Met laboratory, right? So you have 5 minutes. You can share your screen and present your work.
Yeah, actually, I now need to share my screen. Just okay. I have a brief description.
Okay.
So actually, in our paper, we called it PM data. We introduced a new data set with traditional live login data and sport activity data. We make this data set from 3 different sources, from Fitbit Versa to smartwatch, PMSys sport login smartphone application, and from Google Forms. Using these 3 input sources, we mainly collected 2 different types of parameters. First one is objective parameters, and the second one is subjective parameters. Under the objective parameters, we collected heart rate, sleep, calorie consumption, movement distance, weight, and activity sessions. Under the subjective parameters, we collected wellness, training load, injuries, drink intake, food, etc. This dataset contains records for 16 persons for 5 months. Because of this combination of different data sources, this data sets open different research directions in data analysis field and also in machine learning field. For example, we can use this data set to do research for predicting athletes' performance based on live login data or or developing everyday life using live log data. For this dataset paper, we have performed a simple weight prediction experiment. In that experiment, we predicted 3 classes, such as weight goes down, weight goes up, and no weight change. Using simple machine learning algorithms. Basically, we use classification decision tree and random forest tree algorithms in Weka tool. We have done this to show some simple research direction of this dataset. That is just to show some example possibilities. In addition to our simple experiments, we can use this dataset to find correlations between persons' well-being and sport performance, or correlation between different data sources of this dataset. We can use this dataset to do research for handling noisy time series data also, because the collected data has more noisy data points. So we can do some research. How can you identify these points and so on? These are few, but there are a lot of directions to do research using this dataset. Finally, we are happy to see more research from this dataset. So thank you very much.
Thank you. So let me share the Slido window.
Yeah.
Guess we have one question from Said. Thank you for your nice talk. Can you see the Slido?
Yeah,
right?
Yeah.
Okay. Thank you for your nice talk. The dataset is limited to 16 participants. Considering the demographic differences such as gender and age, do you think using this dataset can lead to generalizable results?
Yeah, it is challenging. In this dataset, I think we have a few, this is not the gender balance dataset, because we have 13 males and 3 females. But this is challenging problem. So sometimes we cannot check the gender related parameters and things. So we need more data to do that kind of experiments. Yeah, it is challenging thing. So this is not generalizable based on the gender parameter.
Okay, thank you. I guess we don't have any other questions, so we can move to the second speaker. I will share my screen again. Thank you very much. Is this one? Okay. Okay, so the second paper is about a dataset for exploring gaze behaviors in text summarizations. Very original dataset. So please, Kunyi, can you share your screen if you need? Are you there?
Oh, I don't need to share my screen.
Okay, great. Please.
Oh, okay. Hello, everyone. It's my honor to be here to introduce our work here. We are a team from Tsinghua Shenzhen International Graduate School and Tsinghua University. We provide a dataset for exploring gaze behaviors in text summarization. As we know, automatic text summarization has been a hot research topic for years. Most of the existing studies only use the content itself to generate summaries. Researchers believe that an individual's reading behaviors have much to do with the summaries she or he generates. However, there is no such research or dataset that provides the connection between people's reading behaviors and the summaries provided by them. So our work fills in this gap by providing a dataset covering 50 individuals' gaze behaviors when they are reading 100 articles and composing the corresponding summaries for each article. The dataset is collected by a high accurate eye tracking device and contains a total of 157 million gaze points. Our dataset is mainly composed of 4 parts, namely 100 articles, personal profiles of 50 participants, 157 million gaze points when they are reading articles, and personalized summaries given by different participants. And after some basic measurements and observations, we provided 2 use cases for it. First, our measurements show that users have their own stable reading patterns. Maybe the reading patterns can be integrated into the design of automatic text summarization models to improve their performance. And second, our measurement also shows that there are differences in reading patterns among different people, as well as among the corresponding summaries. Maybe the correlation between the 2 differences is helpful in improving the performance of personalized automatic text summarization. And we believe such a dataset will be available for a wide range of studies. And more details, you can read the paper. Yeah.
Okay, thank you very much for the presentation. So let me share again the Slido. Just a moment. This is the presenter mode. Okay, can you see it? So this is actually a question from me. So interesting and original work. Your participants are all in the same age group, right? So how do you think the dataset generalizes to other age groups, given the nature of the dataset?
Yeah, thank you for your question. We also discovered this problem when recruiting volunteers. However, limited by the experimental environment, we cannot recruit more volunteers of different age groups. And on the other hand, we are not sure whether data obtained by this collection method will be effective for the generation of automatic test summarization. So we first recruited some young volunteers in school. And in fact, we are now trying to generalize a common reading pattern from the dataset and then incorporate this pattern into the design of a model. And if this model can perform better on other open datasets, this proves that our collection method is effective. And then we can try to recruit more volunteers of different age groups and then explore the differences between different age groups. And these works are all still in progress. Yeah.
So you're going to also update in this case, if you will be able to recruit more participants in different age groups, you will update the GitHub repository, right?
Yeah.
Is this your intention? Okay. Okay, so let's switch to the third paper, which is going to be presented by Seila Abdulhamid.
Yeah, can you hear me?
Yes, we can. The paper is entitled LRRO, a lip reading dataset for the under-resourced Romanian language.
Yeah.
If you want, you can share your screen.
Yeah, I will share it immediately. So as you said, I'm Seila Abdulhamid. I'm representing University Polytechnic of Bucharest, and together with my colleague Andrei and our professor Bogdan Ionescu, we have created the first data set for the Romanian language, LRRO. So let me share my screen. Okay, so basically what we did, we saw the work from the visual geometric group of the Oxford University. Okay, I think I'm sharing it.
Yes.
Okay. So we saw the work that the visual geometric group has done regarding the proposed multiple lip reading dataset, then LRW, LRS2, LRS3, these are the baseline, the reference datasets for the visual speech recognition. And we came up with our own data set, the first one in the Romanian language, being an under-resourced language. Our main contribution was generating the classes of words. As I've shared before, this is the Zenodo link, and this is the GitHub link towards our dataset. So if you want, you can download it afterwards and use it. Basically what we did, coming back to that, we had two types of data set, the wild one and the lab. The wild was basically 20 hours of videos coming from YouTube in Romanian language, entertainment, TEDx, and so on. We downloaded the videos and then we started annotating each word. We used a team of annotators because the work was massive, and using the Edges Up tool, we started annotating each word and had the information something like this. As you can see, for each word, we had the start and end date. 1 is the ID of the character that is speaking, the speaker, and M is for the gender, just to have afterwards some statistics. Afterwards, we had, sorry, this one. We had 3 types of classes, let's say, 3 types of folders: test, train, and val. Obviously, test is for testing purpose. The train is to train the instances, the models, and the val is for validating afterwards the data set. Okay. If we go to the train, we can see a total of 21 classes. Classes meaning a word that has more than 6 characters in the Romanian language. You can see, for example, Bucharest. This is the capital city, Bucharest. We have here all the instances where Bucharest was said in those videos, as I've shown you before. The naming is just to anonymize the users. And as you see, we split here in 29 frames. And this is basically the saying of the word Bucharest. If you go to other subfolders, you will find exactly the same thing for the words milioane and so on. This is for the Romanian language, of course. Okay, so going through the lab one, it's basically this, somehow the same as in result. The difference is the source of the videos. They were shot, we had 19 annotators, 19 volunteers that helped us to create 27 videos in front, and using, for example, it's this one, a video on a 30-degree angle. We used the microphone and the prompter. And we had a predefined text using that had 48 different words from the Romanian language. Afterwards, we used two automated speech recognition systems that helped us also, for example, this is the transcript, the original transcript, and then you can see the word for each video. We had the start and the end date of the word, and then we used FFPG to take the word out. And as you can see, we have 48 elements of that each folder represent a class, and it's exactly the same. We have a random named file that has 29 frames when the speaker, we just had the mouth drops, says the word. And afterwards, just for validating, let's say we had two architecture, VGGM and Inception V4 state-of-the-art deep neural network architecture that we wanted to use just to validate the data set. That's about it.
Okay, thank you very much.
Thank you.
So let me share my screen.
Yeah.
So I have a question. Can you comment on the difference of methodologies used from you, so in your paper, in your data set, from other visual speech recognition data sets that were published in the literature? Are you aware of any differences?
Yeah, I think one of the biggest, let's say, is that we use the forced aligner, which forces the lip movement, the alignment between the lip movement and the audio signal, because that is very important. If you have a misalignment between the lip movement and the audio, what the speaker says, on the lip reading part, it's going to be very difficult to implement it. So this is a tool that we used, and it's something that for us, it was very helpful.
Okay, thank you.
Thank you.
So let's move to paper number 4. It's another topic. It's about quality of experience measurement of multipath TCP applications on iOS mobile devices. It's going to be delivered talk by Katharina Keller from Goethe University of Frankfurt. Katharina, are you here?
Yes.
Okay, we can see you.
You can see me? Okay, that's fine.
If you want, you can share your screen. And
yes, I would like to. So
please go ahead.
This might work.
Yeah.
Okay, cool. So just move you. So hi everyone, my name is Katharina and I'm from Goethe University Frankfurt. I'm happy to present the dataset paper, Quality of Experience Measurements of Multipath TCP Applications on iOS mobile devices today. Well, I guess every one of you know that you walk around the house and the Wi-Fi connection gets lost and your video or call is interrupted. So multipath TCP is, that should not work, okay. Multipath TCP is supposed to solve this problem by promising higher throughput, lower latency, and higher reliability for application streams. Although considerable research has been done on the quality of service of multipath TCP, it's still unclear how multipath TCP affects the quality of experience, especially in mobile applications. So my co-authors and I provide a dataset which is supposed to examine differences in QoE between iOS multipath TCP modes while looking at different applications. So for our study, we used an Apple iPhone 7 Plus as a test device, and we selected 3 real-world applications with different degrees of interactivity and network traffic for our survey. So first of all, we selected GeoGuessr as an interactive browser-based mobile game. Second, we selected YouTube as a video stream. And third, we chose Instagram as an example for infinite web browsing. Moreover, we decided to choose the interactive and as well as the aggregate mode for our study. We used a within subject design and presented each usage scenario twice, once with multipath TCP and once without multipath TCP, while the order of the iteration as well as the multipath TCP mode was randomly selected. For investigating the perceived quality of experience, we used a multi-segment questionnaire based on an overall satisfaction scale. So after each iteration, the respondents assessed the absolute quality of experience. And after each usage scenario, they compared both iterations. Moreover, we explored the cost sensitivity in terms of the used data volume. So our data set provides network data as well as survey data within our data set. Based on this data set, we show some preliminary results in our paper for different mobile applications that have different network, quality of service requirements, and user interactive patterns. Although multipath TCP is known to provide better quality of service for the applications running over it, our results suggest that multipath TCP does not necessarily improve application quality of experience. So our data set is intended to help researchers to investigate correlations between the measured network metrics and the QoE results from the user study, and therefore to explore differences in QoE within multipath TCP applications at the network layer. Moreover, researchers may want to investigate the QoE achieved by multipath TCP in relation to the willingness to sacrifice the mobile data volume. Once back, okay. In addition to that, the findings will help developers to select a suitable multipath TCP mode for the application. So this was just a short wrap up of our dataset paper. Thanks for your attention, and I'm happy for feedback or any questions.
Okay, thank you very much. We'll share my screen again. Yes, and we have 2 questions. So the first one is by Thomas Zinner. Which multipath TCP scheduler was used within iOS? How does the scheduler influence the results?
Yeah, we already responded for this question in Slido. So actually, we used the normal, so remote multipath TCP scheduler with a minimum RTT. But it's a really, really great idea to take a look at how this multipath TCP scheduler will influence our results. So this is a great idea for further evaluation and for further research projects.
Thank you. So the second question is by Rajiv. Were you able to find the contribution of particular multiple TCP QoS metrics to the overall QoE? So how does these QoS metrics map to the QoE?
So I think it is very difficult. So actually, I have to admit that no, we did not find the contribution of a particular MPTCP QoS metric to the overall QoE, because we rather focused, or like to map a scheduler to the QoE is very difficult. But we're working on that. So on the one hand, we should work on the scheduler, and on the other hand, we should take this idea into account for further research. I'm very happy for your feedback.
Okay, thank you. So I think that we are on time, so we can also so thank again Katarina, and
yeah, thank you.
Go back to the slides. Okay, so the fifth paper is going to be presented by Alexandre Mercat. I hope my pronunciation is okay.
Yes, it's perfect. Thanks.
And he's going to present UVG dataset, 50, 120 FPS, 4K sequences for video codec analysis and development. Very interesting.
Okay, thanks.
You can share your screen if you want.
Yes, I will try. Can you see my screen?
It's coming. Okay, we can see it.
Okay, so thanks for these introductions. I'm very happy to present you our UVG dataset. So as the title says, it's a dataset of raw 4K video sequences at 50 and 120 FPS. So the best things to present you our dataset is just to show you the videos. So this dataset is composed of 16 videos. 8 of them are recorded at 120 FPS and 8 of them at 50 FPS. As you can see here, maybe some video can be familiar for you as Beauty, because some video was already available in our website for years now, but we introduced new video in this dataset, and in this paper, we also characterize all of this video in terms of rate distortions efficiency. So we use the latest versions of VTM encoder and HM encoder to show how this video completes the video proposed in the CTC set. We also characterize this video in terms of spatial and temporal informations and spatial and temporal complexity. Now I will use my time to show you how it's easy to just get this data set. So you can just go in the website on our team Ultra Video Group, and then in this web page you can see just on the side of our quasar HVC encoder this UVG dataset. So all of these sequences are present here with descriptions and available in different formats. So all of these sequences are available in 8 and 10 bits YUV 420 formats. And some of them are already encoded too if you need it. So to just download, you can just choose which format do you like, and then you have a direct download. So it's really easy to access. So this is for my presentations. If you have any questions, feel free to ask or to post them in Slido, and I will take the time to answer them. Thanks.
Okay, thank you. I will share my screen again. And okay, Actually, there is, can you see my screen, right?
Yes.
So actually, this is by me, this question. So very useful data set. We will use this, so for sure. Have you tried to use VMAF to evaluate rate distortion?
Yeah, we are currently running the test. So, but unfortunately, it's really, really long using VTM. So currently we have the results for all intra codings, but unfortunately the VMAF matrix is not really relevant for all intra, but we will get the results soon for low delay and random access, probably in 2 weeks.
And are you planning also to share these data?
Yes.
That's great.
Yeah.
Okay.
In the next publications, probably.
Great, great. So look forward to it. Okay. Yeah. So thank you very much.
Thanks.
Okay. Let me just update this. Okay. Let's go back to the slides. So we have the 6th paper, which is going to be presented by Dario. Beyond throughput, the next generation, a 5G dataset with channel and context metrics. Also very interested in this dataset. So please, Dario.
Thank you. Thank you. Hopefully you can all hear me.
Yes, we can. If you want, you can share your screen.
Yeah, I am going to share my screen. Hopefully you can see my screen. Can you see the presentation?
Yes.
Okay, excellent. Okay, so good afternoon, everyone. My name is Dario. I will present the dataset paper Beyond Throughput, the next generation of 5G dataset with channel and context metrics. This was joint work done with the Faculty of Electrical Engineering, Sarajevo, and University College Cork, and it's funded by the Science Foundation Ireland. So, as we all know, the 5G has very high promises about the high data rates, low latency, and support for the tens of thousands of the connected devices. So with the first rollout of these 5G networks in Ireland, we decided to go and try to collect some data and see how they behave, and also to provide some bandwidth and channel data set for the future research and the research community. So what we basically did, we ran the phones on the Irish mobile network that supported that, or that first deployed the 5G network, and we collected traces into mobility patterns, static and driving, and also for the test applications, we use the standard way of large file download, and also we run some VOD streaming services. Also, we in parallel also extended or created NS3 simulation with a little bit more large scale 5G setup, and we also generated a synthetic data set from that simulation. Now, in terms of the data set collection, we use the GNetTrack application running in background, which was logging all the parameters with 1 second granularity, and collected different information, which I will come back to later. We used the Samsung S10 5G device, which supported the sub-6 5G frequency band. And also, as I already said, 3 test applications, classical file download, and also we streamed the Netflix and Amazon Prime. We collected this data set over the period of several months. The main reason was that because we would very quickly burn out all the limits that we had per month, or the data cap per month. I think on like if the signal was good, we would like run 80 gigs in maybe half hour maximum. So for the features that we collected, or the data set has, basically we have a throughput, applicant downlink. We also have the latency parameters, which are the ping values ranging and some statistics with that, which I'll show you later. Channel metrics that were collected were SNRS, RSRQ, RSRP, RSRI, and the CQI, and also some additional metrics, including GPS, velocity, and the state of the device. This state is very important when we run the Netflix and the Amazon Prime, because from there you can basically infer the off and on periods. Now, I will just give the quick overview of the data set. Now here we did comparison with the 4G, because we collected similar data set 2 years ago. And we now compared it with the same mobility patterns. And basically what we can see from this first rollout, that we have the improvement in the average throughput up to 50%. And we also managed to get almost over the half gigabit speed as the peak rate. Yeah, and I'm just briefly mention the simulation framework. This basically synthetic data set mimics the production data set, but it's a little bit more larger scale, with up to 20 eNode Bs and up to 20 users per eNode B. And also it allows us to capture network side metrics. Yeah, so that would be the conclusion. So we collected the 5G prediction data set with client-side metrics, and also we have a additional simulation 5G framework with a more large-scale evaluation. Now, I also want to show you how the actually data set looks like. So this is one phase that we collected, and here you can see different. We have timestamps, we have the GPS coordinates, we have the velocity, which here we call the speed. We have operator name. We did anonymize this operator name, but it's we also, to be fair, provide the cell hex and row cell ID, which are not anonymized. So you could probably infer which operator it is, but like I think it's only at the moment only one operator, so it's easy to find. We also provide the cell ID, the network mode. Now the network mode is also important, especially for the driving scenarios, because it will switch between the 5G, 4G, and 3G. Here are our channel metrics, our downlink and uplink bitrate, and the state, which refers to is it downloading or is it idle. And also we have the neighboring RSRP and RSRQ, which is from the base station with the strongest signal, which is the candidate for the handover. Yeah, so that will be that's the short overview. So thank you all.
Great. Thanks, very interesting. I will share my screen again. Sorry, just 1 second. Let's switch to, okay, the presenter mode. Okay. So we have 2 questions. You can see them on the screen. The first one is by Uyen Tran. In terms of bandwidth variations, what are the key differences between 3G, 4G, and 5G networks that we have seen in your dataset?
Yeah, so it's interesting questions. Interesting question. So we did provide some very simple statistics, like in terms of the variation range, and you can see from the variation range that 5G has a much larger variation range, indicating that it has the bandwidth variation oscillates a lot more, and that's true for the static case and even for the mobile case. Now, however, the mobile case is also consists of the 5G, 4G, and 3G technologies, depending on your driving conditions. So, but to answer this question in more precise, we would need to go and analyze this data set in more detail to provide. But definitely, from this initial results, 5G has a more variation than these 3G and 4G, and mainly because of the upper bound, which is now much increased compared to the lower bound, which all of those technologies have the similar.
Yeah. Okay, very nice. So the second, wait, I check this. Mark is answered. So second one is from Amr Rizk. How are the timestamps synchronized, or do you only have RTTs? I'm asking because of asymmetries on the paths.
Yeah, so it's a classical ping, so it's only based on the RTTs.
RTT.
So there's yeah, so yeah, so we don't look at the asymmetric path at all. Okay. To be fair, we do work on we are trying to implement in some other tool the passive way of inferring the latency. That's other work.
Okay, thank you. Okay, so I will switch to, okay. So we have the last but not least presentation. It's going to be delivered by Henrik Svoren from University of Oslo. And the title of the dataset is Toadstool, a dataset for training emotional intelligent machines playing Super Mario Bros. We all like Super Mario. So you can share the screen if you want.
Hello, can you hear me okay?
Yeah, very well.
So I will share the screen here if I can.
Yeah, you should be able.
Yes, here we go.
Yes.
Okay, perfect.
That's
so,
Super Mario 1.
Yeah,
that's the very first.
The very first, the original.
Yes.
Okay, so thank you for the introduction. I will essentially go through some of the slides from the presentation. The dataset that we have created is called Toadstool. It consists of game, video, and physiological data collected from people playing Super Mario Bros. And the original idea behind the dataset was mainly to provide a way of training artificial reinforcement learning agents that has an element of emotional understanding or intelligence. This can be done with this dataset by leveraging the emotional connection between the physiological data signals collected and their emotional reactions in humans. We chose Mario as a use case as it is a simple and well-known game, and it is a good generalized representative of the platforming genre of games. We collected data from 10 participants playing the game for 35 minutes each. We had quite a varied distribution of participants, both in terms of age, as well as gaming experience, and also gender. We collected several different types of synchronized data to be part of the dataset. The gameplay frames are not actually directly recorded, but instead we record the action at each step. So since the environment is deterministic, we can then replay the session at a later time and extract the game frames as well as other contextual information that we might need. The phase frames are extracted from the video, and the physiological sensor data is recorded through an E4 Empatica wristband device. You can see here the Empatica E4. It is graded as a medical device and provides quite high quality measurements using several different sensors. There's the PPG sensor, which is used to determine the blood volume pulse as well as the heart rate. The blood volume pulse is nice because it's a good basis for emotion and can be used as an indicator of immediate visceral reactions of the sympathetic nervous system, like fight or flight reactions. There's also the EDA sensor. This measures electrodermal activity, essentially the electrical conductivity of the skin based on perspiration. And this is also a good indicator of emotional responses in humans. There's also an accelerometer, which captures motion, and a thermometer, which measures the skin temperature. We also did some experiments to create a baseline and for a more in-depth description of the dataset, as well as use cases and to look at the baseline experience, I invite you to read our article. Thank you.
Thanks. Great slide. Okay. Okay, so let me check. Okay. Can you see the screen, right? So
yes.
We have one question from Said. Aren't these data very content dependent? So for example, a horror game triggers completely different emotion than Super Mario. What is your view on that?
Well, yeah, this is very true. The data is quite context dependent. We believe the dataset can be representative of a lot of common situation in platforming games, as Mario is quite representative of that genre, but it's not really transferable to all kinds of different games, like horror games, for example. However, we think it's a good use case to be used as a starting point for applying certain kind of approaches to reinforcement learning for games. And also the methodology and tools that we used are included in the dataset. So the approach can easily be applied to collect data from other games as well. And you could also possibly combine data and to generalize more or to do a more generalized approach to that. Yeah.
Good. So I have just one quick question. It's basically a follow-up. So I don't recall the reading. So I read the paper, but I don't recall all the details. To get so it's not the methodology does not depend on actually the gaming engine, right? So
no, you would have to for the methodology, you would have to switch the actual framework that people played in.
Okay.
For our collection, they played in a framework that was designed for doing reinforcement learning on Mario. But
okay.
so you would have to change that. But
okay.
The other part of the protocol and the collection could be done with any game, essentially.
Okay. Okay, thank you very much. So this actually ends. So we have another question, follow-up question. So let me check this. Okay. Have you tried to create some events to trigger the emotion in the game? For example, add some delay to make the gamers annoyed. In that case, you can see if there is any correlation between the subjective experience and the sensor data. Very interesting question.
Yeah, that is a very interesting question, and yeah, it's one of the things that we thought about doing if we would have had the time. And it's also definitely an interesting thing to do for some future work to get more a sense of exactly what experiences triggers what emotions and so on. Yeah, so it's a very nice idea.
Very nice idea, yeah. Okay, so I guess that now we are done with the papers. So I would like to thank all the contributors to this session. So the first session and this one. I think that it was a really interesting track overall. And I also would like to thank all the reviewers of the papers, and also please continue to ask questions over Slido, and if you want privately on Slack. And so I think that now I should hand over to Laura